Okay, so again, my name's Jason Carey. I'm a data platform technical lead at Lyft. I've been at Lyft for about 4 years, and over the last few quarters, Lyft has decided to double down on investing in data quality and promoting trustworthy data. And today I'm going to talk about one of the systems, new systems that we just built to help achieve that, called Verity. So really quickly, some fast facts about Lyft data. I mean,
Sorry, Jason, I don't think we see your screen.
Oh, let's see. Not sure here. Okay, 1 second.
All right. And while Jason is setting up, I'd like to give a shout out to Lyft's team, who not only build lots of internal tooling, but also open sourced some of it. The most famous projects are Flight, which is a machine learning and general purpose data orchestration engine that basically is somewhat competing with Airflow and is quite opinionated, but also quickly getting traction in the ML community. And the second project is called Amundsen, which is an open source data catalog built on Python stack. So I suggest you all check it out. Very, very cool stuff. So take it away, Jason.
How are we now? We're good? Yep, it looks like we're good. Sorry about that. All right.
We're good.
So sorry about that intro. Let's go to some fast facts about Lyft data. So the backbone of our data platform is basically a data lake. We have our content in S3. We use Hive Metastore. We use Spark and Presto for execution engines. And to give an idea of like scale, we are on the order of about 110,000 data sets, about 40 petabytes of data. And if we look from like a query perspective, just like Presto users, we have about 1,100 daily active users. And one thing I want to call out is when we think about users and when we think about extending the platform and building tooling features, we understand like those users break down into different personas for us. For instance, you have SWEs, you have data engineers, data scientists, ML modelers. They all care about data in different ways. They all have different tools in their toolkit and frameworks they like to use. And so when we build services like Verity, we really try to be mindful of that to get the broadest applicability and highest utility to kind of cover and cater to those different use cases. So simply put, like we have lots of users depending on lots of data. And not surprisingly, many of our users lack trust in the data. And there are a lot of contributors to like why they lack trust. And the one I'm going to focus on today is the fact that while we can get our data to the warehouse reliably and measurably, and we get fast query to it, and it's schematized, there's always been this gap around the semantic correctness of the data and making that transparent, visible, discoverable, and enforced in an ongoing basis. As an example, there might be two fields in your data like start date and end date. Is start date always less than end date? Can end date be null? Can a primary key column be null? What's the tolerance for like the completeness of that column? So a lot of these checks are things that we saw as a gap, like they existed sporadically in code, but they weren't visible, they weren't centralized, and they're really hard to create. So that brings us to Verity. That was exactly what we started to chip away with this system. It's a check-based system to monitor the quality of offline data. And the 10,000-foot view of how Verity works, the right mental model, is 3 things. One, as a check author, which might be a data producer or a data consumer, you define a check. And in the context of Verity, it's 2 things. It's a query. What do you want to count? Think like a Presto query. What do you want to count? And then a condition. Is that count what you expect? And that expectation may be fixed or even better, depend on previous check results or be stateful. So it's a bit more robust to fluctuations in the data. The second part is you orchestrate these checks. So we're heavily reliant on Airflow as an orchestration framework as well as Flight at Lyft. And so the idea is basically run these checks when your data changes. Finally, you have to configure who gets notified and how they get notified when there are check failures. So that's the 10,000-foot view. We're going to dig into a screenshot of like what our product UI looks here. There's a lot going on in this, so I'm just going to point out a couple things. This screen is showing check runs for a single check. And in the table in the bottom left-hand corner, we have various rows. Each row you can think of some ETL running, in this case, a daily ETL. And this particular check runs as part of that to monitor the quality of that data. You have the things that you would hope to have. the observed count, that's what you wanted to count or what you did count. The result is showing a range of like your expectation, your condition. And if you look really closely, that condition range in the result column shifts a little bit, because in this particular case, it's not a fixed threshold. It's actually based on a look back period and using statistics that adapts with your data. On the right side, we have more details about a particular run, a lot of diagnostic information, really to help aid debugging when there are check failures. And I'm going to talk about on the right-hand side the definition and query tabs as well on the next screen, because I think they're pretty important to the user experience here. On the left side, this is if you were to click definition, this is our DSL we built that a check author would go in and configure. It is YAML based, but you can see a couple top-level items tied to what we defined as a Verity check. You have a query and a condition. In the query, it's basically a Presto query where dynamic data, such as a date stamp, is injected at runtime. And in this particular case is configuration for a stateful condition that looks at standard deviations, 3 plus or minus 3 in this case. And while that's good and you can see the definition, what users really want to see is what was actually queried against Presto at runtime, so that when there's a failure, they can move very quickly in debugging and build confidence that what they configured matches their intuition of what's actually wrong. And that's what the query on the right-hand side is showing. This is the actual query. You know what the date stamp has the runtime value. So that gives you an idea of like what the user interface would be like for Verity as you're authoring checks to help debugging. Architecturally, I'm not going to go through all of this, but just point out a few things. On the left-hand side, top left, we have a customer ETL. And again, we are Airflow and Flight reliant. So we had built custom operator. We have a data quality operator. You can use that, anywhere in your flow multiple times when you're doing your ETL. That operator hits our API basically to initiate checks. And one interesting thing about interaction with this system is that you can run checks in a blocking or non-blocking manner. Why is that important? Well, as Gleb was just talking about, if data is going to violate a data contract, delayed data in many cases is better than bad data. So you can run your check blocking, and if the check fails and you'll wait for that failure, the ETL fails and you can block downstream consumption to mitigate the blast radius. Or you can do non-blocking in a sense where it's fire and forget, run the check, don't block downstream consumption, but still be notified when there are deviations. On the API, we're a gRPC-based API. We have various consumers of that. And then behind that, we have the brains, which is the executor, which does the transpiling between that DSL you saw to basically the execution engine. Right now, we use Presto. It ties into the standard notifiers that we have. And then also we store a lot of state about not just the check definition, but the time series of results in Dynamo, which is really useful, one for robust stateful conditions, as well as just triaging and exploring data in the past. So to wrap it up, like how has adoption been for this system? Well, we're still kind of the new kid on the block. We came out of our MVP earlier this year. And while our team shifted in size, I would say about 5 engineers over 6 months, including like onboarding of early adopters. That's about the level of effort we've put in, and we're just getting started. We have about 10 teams. They're all internal right now, working with us, running checks in production. There's about 1,000 checks actually running right now. And we've really put an emphasis on, one, identifying what our core data sets are, the most meaningful for the business, so we could tackle those first. We have about 65% coverage. And what that means is we do things like uniqueness guarantees, volume guarantees, key columns being complete, not having nulls there because that can be catastrophic downstream. So that's what we've been focused on. And as a final thing, like what we think is going to come next and what we're going to focus on is, while we're check-based today, we want to move to more passive monitoring where you don't need a human to write checks for 110 data sets. We want to be able to use the historical state of the data and signals about what's important in terms of query access patterns to just have checks automatically online and take the human out of the loop. So that is Verity in a nutshell. Thank you very much. Appreciate the time.